the first criteria is that the student was absent. The total count when the student was absent should be, again, for strictly fewer than 2 days. For strictly, which means strictly, which is less than, fewer than 2 days. So I can easily say that I can encourage, or basically I can entertain the person being absent today only when his absent count is less than 1, because I know it should be maximum. His maximum absent count can reach to again fewer than 2 days. His maximum absent count can reach to 1. So I can indirectly say I can encourage him today being absent only when his absent count is less than 1, or you can say his absent count is 0. Only then I can encourage him to be absent today, because this is his maximum limit. This is a very important thing. You should make sure. Second is that student was never late, which means L, for 3 or more consecutive days, which means I can tolerate him today being late only when his consecutive late count is less than 2, which means that he was never late for 3 or more consecutive days, which means consecutive late count can be at max 2. So again, it can be at max 2. So I can actually entertain him being late today only when his consecutive late count is less than 2. Only then I can entertain him that he can be late today. Ultimately, I have to return an integer n, which says the number of possible attendance records for length n, which means, okay, for n days, for one student, what can be the number of possible attendance record? Because I want to maintain a dB. I want to somehow maintain dB and I have to pay for that dB. So I have to somehow make sure that this is the possible number of records which I can have. Cool. And you know that the number of records which they are asking for can be very large. So do a modulo with 1 plus 7. That's simple modulo. So one very basic thing which we can easily see right here is that for every location I have 3 options. Either the student, again, imagine it as n days, right? For student, for n days, for every day he has 3 options. Either he can be present, absent, or late. So I can easily see I have 3 options for all the n days. So simply apply a simple recursion and count. So it will be 3 to the power n, which by the constraints will for sure TLE. So we know recursion will not work. But whenever recursion don't work, we intuitively have a thought of DP. But just have a quick verification. Can the DP actually be applied? We can easily say yes. Because at, let's say, the 3rd day, when I have a choice of placing someone as, okay, either the student can be absent, late, or present, I can easily see that this portion is repeating. Why it is repeating? Because I can simply see. I simply want the count of different possible things which I can have. I can easily say that if APPA is there, I can have present at that day, I can have absent at that day, I have one absent and present. So again, this is a valid configuration for me. So okay, it is one way. This will give one way, this will give one way. So I know, okay, both are same. So maybe I can just memorize it so as to not compute it again and again. So we know, okay, we have a repeating problem. So for sure, we can apply a simple memorization. If you don't know, exactly same thing with entire tree, dry run and stuff we have done here. Now we know, okay, we simply apply DP. We know the states for us is simply we have n possible days. So one state is n. I have to also keep track of my absent count. Make sure this is the total absent count and this is consecutive late count. Both have their different significance. Consecutive late count says, okay, consecutively I should not be late more than 2 times. Absent count is at max. I can be absent just once at max. Okay, right? So, okay, I know that I have my n, I have my absent count, and I have my consecutive late count. Again, although I have written also here in the top down, I will show the entire stuff which is written, but going forward, I will take abbreviation of absent count as AC and consecutive late count as CLC, because it is very big to write and the code will become very untidy. So that's the reason I just took it. Don't say, okay, naming convention is all this stuff. I know what's done. Cool. So in a simple recursion, firstly, I always tell, go to the recursive case. In recursive case, I know I have to get the count. So I have to sum up. So one very basic thing which I got to know that, okay, I have to get the count. So I will take the integer in which I will keep on adding the count. So the same way my return type will also be an integer. Okay, these two things are sorted. Now either the person can be present. So if he is present, I can simply say, okay, bro, you are present. So initially my answer I can simply assign and ask again. If you go and look back, you will simply be given a n, which say, okay, I have n days to basically check or monitor my student. So from my main function, I will be simply passing my n. And the very beginning, I have no record of absent count, no consecutive late count. So this is kind of confusion which I will pass in from my main function. Okay. So for sure, I will say, okay, bro, for today, for the nth again, for this today date, nth date, imagine he's absent. Imagine he's present. So I will go and ask my recursion to solve for n-1, right? What will be my absent count? It will be 0. Is it 0? It should be what was existing absent count. That will be absent count because it is a total absent count. So it should be absent count, whatsoever absent count I had previously. And if I was present today, so I have broken down the consecutive late count. No matter I was late, but today I am present. So this consecutiveness has been broken. So simply put as 0. Consecutive late count is 0. Okay, what if I am absent today? Now, I can only encourage you being absent only when your absent count is less than 1. Or I can easily say the absent count is equal to 0. Only then I can encourage you being absent. If this is, then I will simply say, bro, answer again. I'm adding in the existing answer. That's a big fact because I want to count the total number of possible options. Then solve for n-1 again for the remaining days. Absent count has increased by 1 again because of, again, as you can simply see, I was absent, late, and then as I placed absent, no matter what the late was, late consecutiveness has been again broken, right? It has been again broken. So I am good to say that, okay, my consecutive late count is still 0. Now, if it is late, okay, I only encourage him being late only when his consecutive late count is less than 2. Only then I will encourage him being late. What I will say, okay, solve for simply n-1. Absent count will remain as it is. It will remain as it is because it is a total absent count. Remember, it is a total absent count. So it will remain as it is, but the consecutive late count will increase by 1. And I only encouraged him when his consecutive late count was less than 2. So these are the possible 3 options which I can have. Again, I'll simply write this as a recursive code. And I know in the very end, my n will become 0. And I always made sure that I'm going on the correct path, which means I always make sure I was having a valid answer because I made sure the condition is satisfied here itself. So as soon as it reached to 0, I always know it is a good way, one good way. So simply return a 1 when it reaches to 0. Cool. Again, you can start from a 0 also and reach to n also. That's also perfectly fine. So it's totally up to you. So you see, and you know, a simple memorization technique before returning, just memorize, say dp of n, my absent count and my consecutive late count. Just simply memorize it and put it to answer. And simply while going to the actual recursion, just simply have a check. So let's see the code. It's pretty simple. Firstly, I initialize again, although I'll highly recommend, it is okay to write this global dp. I will show you both the ways. Global dp also, like I wrote, and also you can make a vector of vector also. That also I will show you. But okay, I know the maximum n size can be 105, so I just made it 105 plus 1. My absent count and my consecutive late count. Cool. Then I will simply put it as -1 in the very beginning. Then I will go on and solve for n, absent count and consecutive late count. Now I will simply go and check again. This is the same code that if n is 0, have a 1. Here I am simply having a dp check. Then my answer is 0 if I am present today. Then simply exact same code, n-1, absent count and 0. If I am absent today, I can only be absent if my absent count is less than 1. So n-1, absent count plus 1 and 0. If I am late, so consecutive late count should be less than 2. Only then I can afford to be late, which means n-1, absent count and consecutive late count plus 1. And that's the possible options which we have. 3 options. Ultimately, simply return the answer. Make sure to do moderate every step. That's how you can simply see your complexity is n into absent count into consecutive late count. For these, I know absent count can be a simple 0 or a 1. it can be a 0 or a 1. Consecutive late count, I can simply see it can be a 0, 1 or a 2. 0 or a 1 or a 2. So I have two ways, like two options for this and three options for this. So n into 2 into 3 is my time complexity. N into 2 into 3 is my time complexity, and same way for space. Okay. Now, Aryan, how would I know that I have to optimize it? You can simply see that while I am writing my recursive code, same way, the interviewer might ask me to optimize it. So usually we always know to optimize this code whenever you have written the most optimal DP code, it's more or less that you convert it to a bottom-up DP. But how would you even know it? You will simply know by saying for a state n, I'm only accessing n minus 1, which is just the previous state, which is a clear indication that I can optimize my space if I convert this to a bottom-up DP. Now I will keep both the code side by side. This is the top-down DP code. I will simply convert this again. I will simply convert the exact same code to a bottom-up DP code. Right, exact same code. Now, before that, make sure you understand what your code actually is doing, right? Like what the code is writing. Now, again, exact same stuff of DP. In these bottom-up case, we memset, or basically we initialize by a DP value of 0, not by a -1, because we know we have the default value of 0. Now comes that what will be the base case? That's a base case, because in the base case you have n equal to 0. This represents what this represents. N is equals to 0 for all value. Again, if you remembered, I told you n equal to 0 I was able to reach when I was specifically mentioning that for all valid absent count and consecutive late count, I will be able to reach this n equal to 0. And thus, I should easily say that for all valid absent count and consecutive late count, and again, I showed you what are the valid absent count. Valid absent count are 0 and 1. Consecutive late count are 0 and 1 and 2. These are the consecutive late count valid options. For all these valid options, I should make sure that my n equal to 0 should be initialized with a value of 1. So I did the exact same stuff. I went on to absent count for 0 and 1, and for consecutive late count of 0, 1 and 2, I initialized my DP value. Again, n equal to 0 is here. For that's all the possible combination of AC and CLC by 1. Okay, my initialization of this to this is done. Now, we can easily see our recursive code simply says when I am at a n, I should go and ask for my n minus 1. And we also know that for DP of 0, we have already got the answer. We just have to try for n days. So I will try for my n days. I know the possible value, again, the good values. If you remember, I was only going on to good values of AC and CLC, right? So I will only try for the good values of AC and CLC. Again, exact same code like this. Just the case that, okay, I'll try for all the n days now. Now, for all the days, just do the same stuff. When it is present, when it is absent, when it is late. But Aryan, why you did not put the condition of less than and stuff? Because you will get to know soon. Now, if I just copy paste the exact same code, so when it is present, so I initialized, or basically I allotted my answer and said, bro, answer is DP of n minus 1, absent count and 0. So answer for me, okay, it is the same DP value. I'm just simply adding up. If you remember what I'm doing, I am taking answer and then I add up in the answer and then assign it to the DP value. You can write the same way saying, okay, put the DP value here. Same way. So I did the same thing. So in the existing DP value, I'm firstly assigning my DP of n minus 1, absent count and 0. Let's put it like this, n minus 1, absent count and 0. Cool. Now for the next case, when it was absent, adding in the existing answer. This is the answer. Adding in the existing answer. Add what? Add my n minus 1 absent count and consecutive late count plus 1. N minus 1, which is day minus 1. Absent count plus 1. Absent count, sorry. This is this. N minus 1, absent count plus 1 and 0. N minus 1, which is day minus 1, absent count plus 1 and 0. Okay. And then simply add it. Now, this will not hamper me. Again, if you can see that this operation will only be performed when my absent count is less than 1. But here you can easily see that this operation is performed when my absent count is also equal to 1. But this will not hamper me. Why? Because it will go and ask for absent count plus 1. For a value of 1, it will go and ask for absent count plus 1, which means it is going and asking for dp of whatsoever plus 1, which means again, if it is plus 1, so here it was 1 plus 1, which is 2, and then whatsoever value is here, no worries. This is already by default initialized to my 0. As you can see, my limit which I put is 3, 4. So other values which are not in this range are already by default 0. So it is the same way saying that Aryan, I put this limit. It is the same way saying that I modified this, and I let's modify this condition and said answer is equals to answer plus, if absent count is less than 1, simply return the solve function of n minus 1, absent count plus 1 and 0, else return a 0. So this is, again, for this else condition, I am saying my dp default value is 0 itself, which means my solve function of n minus 1, absent count plus 1, 0. If my absent count goes beyond the actual limit, it will by default to 0. So if I invert it to dp, if I remove it to dp, then I'm simply saying I can club these two conditions, because I know that this, if the absent count goes beyond, which means if the absent count goes, if the absent count goes beyond the limit, it will by default will turn back to a 0. So I'm safe in this case. If you want, you can put the condition also. It's totally up to you to actually replicate, but I just make it a bit code shorter. Now for the last case, when it is late, simply same way, my existing answer, I am adding the n minus 1 absent count and consecutive late count plus 1. N minus 1 absent count and consecutive late count plus 1. Cool. Now when these three conditions are done, I am sorted. Ultimately, in the end, if you remembered, for this case, you called from the main function as solve. If you remember, okay, I'll show you. You called solve n 0 and 0. Same way. So for me, I replicate the exact same code, so I can simply write my answer is dp of n 0 and 0. Again, there is another way to solve it. Again, this is code is done. It is perfectly fine. But for the people who want to know, okay, is there another way? There's another way also to solve the exact same stuff. That rather than doing entirely here, you can put your dp of 0, 0, 0 as 1. Don't write this code. And then when this portion is done, again, you have to modify the if condition stuff if you want. But when this portion is done, make sure to, for a specific n, go and try for all the positive values of AC, good values of AC, and all the positive values of CLC. Add them up and then return the answer. That also is one way. But okay, I like the exact same replication way, so I just choose this way. Now you have converted your code to the bottom of code. This is exact perfectly working code. Exact same replica of the top-down DP. Again, complexity wise, everything is still same. Exact same space and time complexity. Now you know that you can simply optimize it by simply looking at that you are, for a day, you are only accessing my day minus 1. That's it. For a day, day minus 1. Day minus 1. So I don't need this redundant DP size of 1e5 plus 1. What I will do, I will simply again exact same code on both the sides. This is the bottom up DP. Now I'm optimizing that bottom up DP code. I will simply say, bro, the existing code which you had, remove it, day, remove the day, remove the day. Instead of DP of day minus 1, make it as a prev DP. As a prev DP. Again, this is my prev DP. Prev DP. This is my prev DP. Prev DP. And I know on every cycle when this is done, I should say, okay, my prev DP is actually DP, so that it can go. Prev DP can actually circulate. Now, for this case, again, it's a question for you. Will you initialize it with DP or prev DP? For sure, people might even think of, if they're just copy pasting, they might think it is a DP. It is not, because it is the first condition. It will be a prev DP. Why? Because in the very first case, when day equal to 1, I will go and ask for day minus 1. Day minus 1 was a day 0, and day 0 is prev DP. So you have to put it as a prev DP here. And ultimately in the last case, simply return my dp of 0n. You can also return the pref dp of 0n. That's also will, so completely fine, will work. So this is the only change which you have to do. Again, make sure that you remove this and make two DPs, DP and pref DP, and that's your only change in the existing bottom-up code. Let's see the code. I made a DP and a pref DP. I removed that factor of n. Now I have just these factors only. Now exact same code. Here it is pref DP. Exact same code. Here it is DP, 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 pref DP, pref DP, pref DP. Again DP, DP. Ultimately, make sure to assign my DP, like pref DP to DP. Ultimately, return the DP. Here you can also put the pref DP. It will also work. Ultimately, what you did, time is still same, but you optimize the space. Space is only used as 3 into 4, just twice, which is roughly saying it is constant. And that's how in the most optimal time and space complexity. Again, you just thought of recursive code. Everything turned out to be automatically. Like from recursive, you wrote bottom up. Sorry, from recursive, you wrote top down code. From top down, just copy pasted and wrote the exact same bottom up code. And then you just removed few lines, and made it as a bottom up code. And that's how you simply solve it. Cool. If you guys liked it, then please do smash the like button. It helps us a lot. Your comments, your love is the only motivation for me. So if you can give it, I will be very grateful. Cool. Bye bye. Take care. Make sure to join Discord if you want to learn. Bye bye. Take care and practice on practice every day, kind of. Bye bye. Take care.